Okay, now that you have a deep understanding of moon phases, we can move on to the closely related topic of eclipses. So there are two general types of eclipses. There's a lunar eclipse and a solar eclipse. So the difference between a lunar and a solar eclipse basically comes down to what order the sun and the moon and the earth are in. So for a solar eclipse, the moon blocks out the sun as seen from Earth. So this is a schematic here that represents the solar eclipse. We have the sun and the moon slips in front of the sun and blocks it out as appears from Earth. For a lunar eclipse, we have kind of the opposite situation, right? We have the sun, we have the earth, and the earth blocks out the sun from hitting the moon. And so we will get really kind of this red color you see here, this red colored moon. If you have a hard time remembering this, there's a cosmologist, Katie Mack. She managed to do this in emojis. A lunar eclipse, remember, the Earth is in between the moon and the sun. The solar eclipse, the moon is in between the Earth and the sun, but an apocalypse is when the sun finds itself between the Earth and the moon. So let's go back to the schematic for a second and examine it a little more closely, right? A lunar eclipse happens when the shadow of the Earth blocks the light from hitting the moon. So this means that the moon for a lunar eclipse is always in its full moon phase. In the same vein, Earth experiences a solar eclipse when the moon blocks out the light from the sun, which can only happen when the moon is in its new moon phase. If you see how this is, the sun would be illuminating this far side of the moon. So we would be seeing a new moon. And this is basically the only time that a solar eclipse would be possible. Up here for a lunar eclipse, under normal circumstances, the near side of the moon would be illuminated by the sun, but it's lined up in just such a way that the Earth blocks the sun. So this would have to be a full moon phase. So let's revisit lunar phases to really understand why this is. Remember, during a new moon, the moon is in between the Earth and the sun. This is the only place in its orbit where the moon can block out the sun, right? So we have sunlight coming from this direction, Earth here. This is what the moon always looks like, with half of it being illuminated. Out in the outer ring here, this is what it looks like from Earth. So at a new moon phase, we have the sun coming in and not illuminating the side of the moon that we can see. So similarly, during a full moon, so when the moon is over here, getting the full brunt of sunlight, this is the only time that the Earth can get right in between the moon and the sun to block out all of this sunlight from hitting the moon. So it might be at this point that you would wonder why we don't get a lunar and a solar eclipse every month, right? We get a new moon and a full moon every month, but we don't get eclipses every month. So really, why do we get these phases at all? So we can kind of think of the solar system as existing on a plane, right? Like little plastic figures riding around on a turntable. So the orbits of these planets are basically all parallel. Like they're all kind of like sitting on top of this plane, on top of this record, going around in a circle. But the moon's orbit is a little bit tilted with respect to that plane. And we call that plane the ecliptic, which is something we will talk about in later lectures. But the moon's orbit is tilted about 5 degrees. So as the moon travels along its orbit, it will often find itself above the plane or below the plane. So at these locations, it can't get directly in line with the Earth and the sun. It's always going to be a little bit below or a little bit higher. Twice a year, though, it's actually possible to have these eclipses, and that's at these what they call nodes, kind of this intersection of the moon's orbit and the plane that all of the planets kind of orbit on. So the moon's orbit not only has to hit one of those nodes to get an eclipse, but for a total solar eclipse to happen, you need the moon to be at the right distance from the Earth. Total solar eclipses work because the sun and moon have roughly the same angular size on the sky, about half a degree. But that can change depending on the moon's orbit. So the moon orbits the Earth in an ellipse or a slight oval shape. We'll talk a little bit more about this later, about orbits later, but just know that orbits are always shaped like ovals. That means that sometimes the moon is closer to the Earth than at other times. When the moon is far away from the Earth, the moon is just a tiny bit smaller on the sky, um, enough smaller that it won't totally block the sun. So when that happens, but the other alignments are right, we will get something called an annular eclipse. So something like this happens when the moon is what we call at apogee. So when it's further from the Earth than normal, we get this ring of fire eclipse. But as if the moon is closer, so maybe at perigee, so at its closest approach, it will look big enough in the sky to completely block out the sun. So we get a total solar eclipse, or it's capable of giving us a total solar eclipse. You might know from a recent eclipse that not everyone sees a total solar eclipse when one happens. And that has to do with the different regions of shadow that extended objects like the sun creates when it encounters something like the moon. So in this module, I've included a video that demonstrates how this happens that I encourage you to watch. But essentially, if you are in this umbra region where it casts a dark circle here, the light source is completely blocked out. And if you're in the penumbra, which is kind of this lighter shade and extends beyond here, um, the light source here will only be partially blocked. So let's look at how this plays out in solar and lunar eclipses. So the bottom panel here is a solar eclipse. You have a dark spot right here in the middle of the umbra and a larger gray circle. That is the penumbra. So usually those in the umbra will see a total solar eclipse. Those in the penumbra will see a partial solar eclipse. And those outside of either one of those circles won't see anything out of the ordinary, right? They will miss the solar eclipse entirely. So the region that you can actually see the total solar eclipse is it's pretty small. It's usually only about 100 miles wide. Um, so this is one of the reasons why there are people that consider themselves eclipse chasers. So whenever there's an eclipse, they will travel all over the world to see it, because you can really only see it in a tiny portion. And this will sweep a path across the Earth as the Earth rotates and as the moon travels across the sky. But compare that to a lunar eclipse, like this top panel up here. So compared to the moon, the Earth casts quite a large shadow. So it's comparatively easy to completely block out the sun. So this means that during a lunar eclipse, if you can see the moon where you are on Earth, you can see the eclipse. A lunar eclipse isn't confined to a small area like the solar eclipse. The next lunar eclipse starts just before midnight, actually on March 13th of this year, and goes until about 6 a.m. on March 14th. So it's several hours. It'll be visible in its entirety from around Albany in the capital district. And that's one thing I like about lunar eclipses, right? They can last for hours. You don't need any special equipment. Um, you don't need those special glasses like you needed for a solar eclipse. You can just view it with your eyes. And as long as you can see the moon, so if we don't have any clouds and you are happen to be out between midnight and 6 a.m. On March 13th, then you should be able to see a pretty cool show. This is very different from solar eclipses, right? You have to be in the perfect spot. You definitely need your special glasses to look at the solar eclipse safely. It only lasts a few minutes, but we do have a partial solar eclipse coming up on March 29th. It will be pretty hard to view, though. It'll be less than 50% covered, and it basically happens at sunrise on March 29th. But if you're very dedicated and if you still have your eclipse glasses from the April eclipse, then you may be able to actually get up and see it. So what's cool about eclipses is that we know enough about them and their orbits, like the moon and sun and the Earth and our orbits around each other, to predict eclipses like 100 years in advance. People have studied eclipses for so long, and they've helped us really figure out what is orbiting what.